my colleague Giulia Granellini, so in charge of operational marketing for composites, is also online and will help me for the question at the end of the presentation. So I'm going to start with a quick introduction about advanced materials and about HUNTSMAN Corporation, so that you can understand who we are. Then I will go through a presentation of the solutions for pressure vessels, which means a portfolio of products and the manufacturing processes that can be addressed. In the third part, I'm going to explain how we can support pressure vessel manufacturers in their developments through testing, through process simulations, and finally we go to the Q&A session. So let's start now with the presentation, short presentation. So HUNTSMAN Advanced Materials is part of HUNTSMAN Corporation, which was created more than 50 years ago. HUNTSMAN is a global manufacturer and marketer of differentiated chemical products. In 2020, we generated $6 billion revenue, and we are about 9,000 employees worldwide. We are segmented in 4 different divisions: polyurethanes, performance product, textile effect, and advanced materials, where we are taking care of the pressure vessel activities. So we have a large range of products covering composites applications. We offer resin solutions for various processes, which can be RTM, high pressure RTM, wet compression molding, filament winding, pultrusion, pre-pregging. And we are serving different types of markets, such as aerospace, automotive, sports and leisure, wind energy, oil and gas. Then we have product range linked to adhesives, polyurethanes, epoxy, MMA solutions. Then we have specialty components for formulators. And finally, we have encapsulation and impregnation solutions for the electronic market, the power industry, and e-mobility. So an important point and common point in all of our developments and also our actions nowadays is the sustainability. We basically act on 3 different pillars. First one is the product safety. So every time we develop new products, we do our best to remove or not use any substances of high concern or substances labeled as CMR, what we call carcinogenic, mutagenic, and reprotoxic. So it's the case for the new developments, but also for the old formulations. We do our best to replace, and we follow the regulations accordingly. Then the second pillar is that we nowadays incorporate more and more bio-based and renewable raw materials in our formulations. For example, in epoxy resins and epoxy hardeners, and we measure this with the biorenewable carbon content, which can be up to 80% in the commercial products. And the third pillar is linked to a program we call Horizon 2025, which targets to reduce our footprint on the environment by the reduction of water usage, reduction of greenhouse gas, waste disposal, and energy consumption. So after this introduction, let's go back now to the solutions for pressure vessel. So the market of fuel cell vehicles is expected to grow significantly by 2030, in the next decade, basically. There are different indicators, OEM decisions, government actions, incentives, global projects, and we can see that everything is moving very fast in this direction right now. It will concern a large range of vehicles, including road transportations, including aerospace, rail, maritime sectors, and whatever. If we talk about Type 3, Type 4, even Type 5 composite pressure vessels, we really believe that they will play a key role in the hydrogen storage and transportation. And the objective here is to introduce the latest innovative solutions that we have to go through this journey. So why working with us on the development of pressure vessels? The first reason is we are an experienced partner. We are involved in the pressure vessel industry for more than 15 years. We have developed and we have qualified epoxy systems for the CNG and in the automotive industry, and more recently in hydrogen applications. Secondly, we are not only a chemical supplier. We would like to position ourselves as a solution provider. It means that when we develop the chemistry, we are looking at the big picture to make sure that we meet all the requirements of performance, that we meet the requirements of processing, and on top of that, we support as much as we can our customers to maximize their chances of success. And finally, we are willing to understand the requirements and the regulatory landscape. We would like to put ourselves into the shoes of the customers to understand their challenges in the design, in the process manufacturing, and make sure that we speak the same language with the customer. We have two main objectives: ensure safety, first one, and second one to increase productivity, actually to follow the increasing demand. And when we talk about safety, we more or less refer to material performance, meet stringent requirements, meet safety margins. So we are having a look at some of the requirements listed here for pressure vessels. The ultimate burst pressure, which get very high when we talk about the 700 bars service, because in burst pressure it means 1,400 bars. Then you have the hot wet resistance with the service temperature up to 85 Celsius in various humidity conditions. Then the pressure cycling defined, for example, in the global regulation, so the GTR number 13, which is quite drastic, and then some criterions of impact resistance. There are many more, but we just listed here some of them that are important, and we see very important when we develop the resin system. And when we translate those ones to the resin system requirements, we establish a kind of specification chart where we pay attention to the TG, which should be above 115 in dry conditions. We try to get the highest tensile strength and elongation at break, which will influence the ultimate burst pressure. And then we work on the fracture toughness and adhesion to fiber to maximize the endurance testing and the fatigue resistance, and as well as the chemical resistance to protect the fibers against the environment. Then, having those products developed, or during the development of those products, we consider the manufacturing processes. It's very important to increase productivity, to be cost effective, and here we don't want to limit ourselves to only the classical wet filament winding. So we are working on 3 different manufacturing processes: the wet filament winding, first one, the resin transfer molding, and then the top break filament winding, which is catching a lot of attention nowadays. So let's start now to have a look at the wet filament winding. So it's the main process to manufacture pressure vessels, and it will still be in the next years and even decades, because it's well established, it's well known, the equipments are available, and we even know what are the limitations. Nevertheless, at HUNTSMAN, we keep working on those solutions, so we keep working on resin systems for this process. Here on the table, on the right-hand side, are reported 3 different resin systems. And the common points of these systems are the following. We have always a thermal resistance above 115 Celsius. We have a long pot life. We have a low viscosity for fast impregnation. And most of those systems are already qualified for CNG and hydrogen high pressure pressure vessels. Moving to the second one, the resin transfer molding. So first of all, how does it work? It's very simple actually. So we take an inliner, which is a thermoplastic inliner. we wind or we braid some fibers around, and after this kind of preform is made, we put it into a mold, a closed mold, we put vacuum, we inject resin under pressure, and then we cure very quickly with the mold. There are many advantages. First, it's a clean and closed process. Secondly, it allows short manufacturing time. Short manufacturing time because injection times are few minutes, and curing time can be as low as 20 minutes. We have demonstrated this in real conditions on real geometries. And the last point is we have a very good laminate quality with low porosity content, and it's pretty consistent. The things, so one point is this resin transfer molding process is relevant for small size vessels. Of course, obviously, for larger dimensions, it doesn't make sense, investment in molds and so on. But for small dimensions and large series, that can be an alternative process, an interesting one. And we have here one resin system which is already qualified, which brings an optimized ratio between injection time and cure time, and as well bringing a very high fracture toughness. Then the top ring. So the last but not the least, so top ring filament winding. One point is, I would like to clarify here first is that we are not top ring suppliers, but we supply the resin system used to manufacture the top rings. So we work either directly with pressure vessel manufacturers with a concept of in-house top rigging. It means manufacturing in situ their own top rig, so they can choose their own fibers, they can choose the resin systems, the grade that they want, the fiber volume content that they need. It prevents lots of logistic issues, cold storage, cold transportations, and so on. Or we can work also on the supply of those resin systems to fiber manufacturers who wants and top rig manufacturers who wants to sell their own product. So all of those players have understood the advantages of this type of product. It's also a clean process. It provides very high reproducibility, a very constant and consistent resin content, a very fast winding speed, up to 5 meters per second. And as well, we could demonstrate that we can shorten a little bit the cure times versus wet filament winding. We have two examples of systems here, which are latent epoxy formulations. So the first one is, for example, a half-life, a shelf life up to 1 month at room temperature, and this can be further increased if you, of course, reduce the temperature between 2 and 8 degrees, for example, then you go to several months. And yeah, so another point is that we work on the kind of low viscosity concept to make a very easy and fast tool impregnation, fiber tool impregnation, even at low temperatures like 30 to 50 degrees Celsius. And then the last point, characteristic of this is we work with low tack, because then when you unwind, when you are manufacturing the pressure vessel, you need to get fast and you cannot stick. So the bobbin should be able to release easily the tow. So on this slide here, it's a summary somehow of our portfolio. And this graph reports the tensile strength versus fracture toughness. As mentioned, the performance of the system is key to ensure safety. And here I would like to point out that we are basically designing the system for different requirements, and different players in the market have different requirements. So we would like to cover all the demands and meet the specific requests as well. So here we can identify each dot is actually a resin system that we reviewed before, and all the color chart correspond to the different manufacturing processes I was just talking about before. And here we can identify two different groups of products. The first one is high tensile strength and a regular, let's say, standard fracture toughness. This is because some of the customers, they don't care about the high fracture toughness because they manage the impact resistance, or they manage differently the aging or the endurance test based on their design. And they favorize, in this case, some cost-effective resin systems that are correspond to this first group and category. And then we have a second group here with very high fracture toughness and still a very good tensile strength. And this one is designed to address a high need for endurance testing, for impact resistance, when people, for example, cannot put any end caps or the covers on the domes, thermoplastic covers to protect from external impacts. So then customer support. So this is an important part of what we offer. And here I would like to give you an overview of first the simulations. I will get back on a few slides later, just after. Then the testing, we have here in Switzerland, in Basel, a test laboratory, which is ISO accredited, so we can run every test in neat resin or on composites in static or dynamic conditions. And then we have also a processing lab, an application lab, where we can deal with RTM manufacturing, where we can do also filament winding. We can manufacture the resin coupons, we can manufacture the composite coupons, and having everything in-house with the accreditation saves a lot of time in some projects. We can do everything at the same time internally. So now simulation capability. So we are talking about process simulation, and the objective here is to visualize what's going on during the process at any time and at any location of the composite laminate. So first of all, we can monitor the temperature evolution within the laminate. So this is very important to prevent temperature overshoot, which are due to the exothermic behavior of the epoxy resins. Especially when we want to go for fast cure, we can generate uncontrolled temperature overshoot very high, above 200 Celsius. So it's important to keep everything under control, because otherwise you have a risk of creating some defects in your laminates or generate internal stresses that will go for cracks. And as well, to protect some of the components of the pressure vessel, like the inliner or even the sealings or the adhesives at the connection on the both parts. We can also visualize the degree of cure. Thus, this will help to optimize later on the productivity. So, as you can understand now, we can already reduce development times by reducing the number of tests and reducing the number of iterations. We select the resin system first, then we determine initial processing properties, parameters, cure temperatures and times. And then when it comes to real testing, we save a lot of time. And after this, when we keep moving forward, we make the model even more accurate, and then we can even further increase productivity, just having the right time and the right temperature in order to reduce costs and being productive. So I would like to thank you for your attention, and now I suggest we go through the Q&A session. So let me check what we have here.
So, Sebastian, we have some questions for you. Can you help us understanding why higher resin content for the RTM produced pressure vessel could be beneficial? What is the gain or the advantage associated to it?
Yeah. So, okay, so actually it's not exactly an advantage in this case, it's more a consequence of this kind of process. So basically, we cannot go higher than 60% fiber volume content in the RTM conditions, especially because we are dealing with thick laminates. But the main advantage here in this technology is to have a very low porosity content, because in the RTM conditions, we can have everything under control. But it's true. It's not. It's kind of mentioned in presentation like an advantage. It's not really an advantage. It's more a consequence of this type of process.
So thank you very much. Another question. What range of elongation at break do you recommend for the epoxy resin systems for this application?
So so the higher the better. The thing is, in general, we need to balance all the properties. So and especially having the thermal resistance means you somehow increase the stiffness. If you increase the stiffness, you reduce somehow the elongation at break. So it's always playing with the balance, but generally we manage to have a tensile elongation at break on each resin, which is above 6.5%.
Thank you very much. Another question, what about aluminum liner pressure vessels? Can we use, for example, the LY3508 resin system also with filament winding processes, or what is your suggestion for this kind of application? So filament winding plus aluminum liner pressure vessels.
Yeah, so we don't have any limitation on the liner. So as mentioned, we work with type 3, we work with type 4. So we don't have any, let's say, difference in the resin system recommendation. Basically, you can work fine with this resin system as well when you consider an aluminum liner.
So another interesting question, what we foresee for the type 5 pressure vessels?
So this is an interesting question, and the main limitation right now is the permeability of the laminate and micro-cracking that can be a problem in this permeability. So however, in this case, the higher toughness system, so the high toughness is really a plus to manage this kind of problem. Because then you reduce the micro cracking and then you keep your permeability.
There is another question. Do we have the possibility to share which software we use for our simulations?
So actually we use different type of software because first we do the acquisition, we make the material database. So basically how it works is we generate a lot of DSC data and then we feed a database. We process this with niche kinetics, I think. And then we process it with software to get the, the name is not coming back. Console server. And then we can compute and have the graphs and generate those graphs.
Thank you. Another question, do you have some requirements or do you have some hints concerning the pretreatment needed to the liner, especially for type 4 pressure vessels to apparently enable the bonding between plastic liner and reinforcement?
Yeah. So of course, bonding thermoplastics is never an easy task. In this case, you can use surface treatment, you can use primers, but for cost reasons, we have lots of customers working without any treatment. What is also important is just in brackets, because it's not exactly the sense of the question here, but when using polyamides, it's important also to pay attention that you don't catch so much humidity before winding. And this drying process is highly recommended.
Thank you. There is another question around our resins being suitable or more specific resin, or I would dare to add also components for cryogenic tanks without thermoplastic inliner.
Yeah, so in this case, we are working with a different range of products. So basically we are targeting the temperatures of minus 180 Celsius. they were not presented here in this presentation, so we work specifically case by case. And if you have a specific project or request, I would like to invite you to get in touch with me, and we can discuss separately about this topic, and I can recommend the products that we are working with.
And one last question. Can the pressure vessels produce our resin systems be recycled at the end of the life?
Yeah, this is an interesting question. Of course, they are not thermoplastics, and so we are working with thermosetting resins, which are quite difficult to recycle for the time being. Why we're still using thermosetting is because they give these very specific properties and performance that is needed to ensure the safety. But at the end of the day, there are many actions, or there are many companies working on the topics, and of course we are looking closely at this because it's an important topic for the sustainability of those applications.
So thank you very much, Sebastian. You answered all the questions, so which I have had in the Q&A session.
Okay, so if we don't have any other questions, I think we are going to close this meeting. I would like again to thank you very much. If you have any further questions, please feel free to contact me, or if you want more detailed answers, my email address is there. You can also find us on the booth of HUNTSMAN at the GEC Connect event. So feel free to get in touch with us. And so I wish you a nice show.
Bye. Thank you for joining. Ciao.
Thank you.